going to be a recap of Unit 2, Lesson 3. And in this particular lesson, I'm going to review how to completely factor using a method called grouping. So here is the first one. Please write it down with me. 36 x cubed plus 27 x squared minus 4x minus 3. So I'm going to have four terms, and I want to know how to completely factor this. I'm going to focus on those first two, and I'm only going to look right now at the numerical values, 36 and 27. And I need to figure out what is the largest number I can factor out. So I personally start with the 27, okay? I start with the smaller of the two. And I'm like, okay, what numbers can go into 27? So what numbers nicely divide into 27? Like 9, 3, 1, 27. There's only four options. So I start with the largest one. And I divide 36 by 27. Oh, it's not a nice whole number. It doesn't work. So I go to the next largest number. I know 9 goes into 27. Let's see if 9 goes into 36. It does. So 9 goes into both of these. I do need to factor out the largest numerical value. So I take out a 9. I also look at the x's. This has, if you're visual like me, this has 2 x's and this has 3 x's. The most I can take out of both groups is 2 x's. Now what would I be left with? 9 times 4 is 36. I need 3 x's total, and I only have 2. I need to attach one more. I want to make sure I did this right. So 36 x to the third. Okay, great. Now I need to get with 27, a positive 27 at that. 9 times what is positive 27? 3. I need 2 x's, well, I already have them. That's the first step. Whatever is in parentheses, I'm going to take that. It's going to be like a computer. I'm going to copy and paste it back here. 4x plus 3. And then I'm going to put a really light question mark in front. Now there's this magical number. If this is factorable, there's a number that I can take. And when I distribute it to the 4x, I end up with this portion. And when I distribute it to the 3, I end up with this portion. Let's see if that number exists. If it doesn't, I can't factor this. So is there a number I can take times 4x and get negative 4x? Sure, negative 1. Well, let's see if this works. Okay, I distribute, yes, I get negative 4x. I distribute, yes, I get negative 3. Okay, great. So what do I do next? Think of this as like a front half and a back half, okay? See how they both have the exact same parenthesis? I write that parenthesis down just one time. Now, what's in front of the first parenthesis? 9x squared. What's in front of the second parenthesis? Negative 1. Remember, the directions are to completely factor. So when I look at this, I don't see like an x squared, so I can't take it any further. Here I see an x squared, and I have subtraction. Remember, this is the binomial expressions. These are the binomial expressions, so I do need subtraction, and I would need to have like an x squared. This number right here has to be divisible by 2. Okay, now is 9 in one part of that list? Look at the board that has the numbers that say like 1, 4, 9, 16, 25. Those are those perfect squares. Is 9 on that list? Yep. Is 1 on the list? So I'm going to break this down. So the 3 x's came from the front, they stay in front. The 1's came from the back, they stay in back. One of these is positive, one of these is negative. It doesn't matter which one. And don't forget about the 4x plus 3 out front. This is completely factored. Sometimes students say, think of this as like 3 different coins, and the order you write the coins in doesn't matter. Each one of these is referred to as a factor, and the order you write them in doesn't matter. That means this 4x plus 3 could be in back, it could be in the middle. What matters is that you have each of these 3 groups. Each of them are called factors. Okay, next one. Please write down 8x cubed plus 4x squared plus 2x plus 1. So I'm looking at this very front, and I'm going, okay, so 8, did it just freeze on me?